In this video, we're going to continue topic 10.13. We're going to be looking at example 4a. We're going to talk about the interval of convergence, and we're looking at these for the function, the derivative, and the integral once we get through this entire example 4. So I'm going to just start with the original function. So we know we have to plug in n plus 1 using the ratio test. So I'm going to have this sum as n equals 1 to infinity of x to the n plus 1 over n plus 1, absolute value of it, and then I know I'm divide by the original or I multiply by its reciprocal. And we're going to rearrange a little bit. So we've got the sum as n equals 1 to infinity of x to the n times x times n over x to the n times n plus 1. And we know we get to cancel these x to the n's. I know that these, when I look at the limit on the n's, because n's only, and I wrote this wrong. It should have been the limit out here. I apologize for that. So this is the limit as n approaches infinity, not the sum. So as I plug those in, I know that I get just a 1, so I would just get the absolute value of x, which we want to force to be less than 1, which implies that the interval is between -1 and 1. Now I want to test the endpoints of that interval. So I'm going to say that x equals -1 first, and I'm going to plug that into my original function. So I'm looking at the sum as n equals 1 to infinity of -1 to the n over n, which means I'm going to use the alternating series test. So AST, I'm going to look at condition 1, which is going to say, hey, I need the limit as n approaches infinity of 1 over n, which we know is just 0, so it meets condition 1 of alternating series. Condition 2 is the terms have to decrease. I'm going to substitute in 1 over 1, 1 over 2, 1 over 3, 1 over 4. They're definitely decreasing. So therefore, this one's converges by alternating series test, which means that this is an equal to on my interval. So now we're going to plug in, let's plug in x equal to 1. So we've got the sum as n equals 1 to infinity of 1 to the n over n, which is really just n equals 1 to infinity of 1 over n, which we know actually diverges because that's harmonic. So therefore divergence, or it's a divergent harmonic series. So I do not include the endpoint. So this is what my interval looks like for the original function.